Hi, in this video we are going to go over the solution of the problem k smallest elements in an array. We already covered the k largest elements and the solution is exactly the same. That's just a small modification on the code. So if you remember, right now the code that is here is for calculating k largest, and for example for this array I can calculate at the end 9, 10 and 12 as the 3k largest elements. And if I want to, and if you remember, we used heap mean for that was giving us as the first element of the heap list the smallest elements. Now one way of solving this problem is still using min heap function that is available in Python, but right now we need actually max heap. So the solution to that is actually very simple, and it's a little tricky, but just consider that these points, if I consider negative value of them and calculate the three k largest elements, it's actually k smallest elements in a normal situation. So let's see how that works. So let's consider that if I multiply each point by -1, and here this is a print, doesn't matter, but I do that, and the other place that we have is this one. So if I just multiply each point by -1, I'm adding -2, -9, -2, -5 to the elements. So let's run it to see what we get. So as the three elements I add -2, -9, -5 to the elements, and then I go to the element, the points, which is now -6, and I say, is -6 greater than -9? Yes, it is, because this is a -6 is larger than -9, so I replace that in the list. Then I go for the next one, is -4 larger than the smallest elements here, which is -6? Yeah, it is. So I replace the -6 with -4, and so on. So if we continue that, we end up having these three elements, -3, -2 and -1, which are technically three largest elements if all of the points are negative. And in a normal situation, when points are positive, these three elements are the k smallest points. So if you look at here, so you see the 2, 1 and 3 are smallest points. If you just want to, instead of printing out the k largest, you can just simply return the negative value, which is what we need, -x for x in k largest. So let's run that. So you see I can return the 3 to 1, which is our three smallest elements. So this is technically exact same solution, and the only thing that we're doing is just we are still using min heap, but instead of changing anything, we just consider the negative value of the points. We add the negative value of the points initially to the heap. Then when we compare the negative value, and when we replace in a min heap, we also replace in a min heap, and at the end, just if you want the positive number be returned, you just loop over the k elements and consider that one. So time complexity and space complexity, if you want to calculate that, for the only thing that is added is just this line, which is we are looping over k elements. So it's still k, like the previous one. We just need to add 1k, which will be ignored as we are getting the limit to the infinity of n, so it's gonna be ignored. So time complexity will be the same. For the space complexity is also same, because we always have that heap, that the size of that remains as k. So this is a simple trick just to how we can use max heap, because the function that we have in Python is for min heap. If you want to have a max heap functionality, so you just consider negative values. So that's the solution of this problem, and thank you so much for watching this video.